Today we're going to be talking about dot and cross products of vectors in three-dimensional spaces. So first, we're going to look at the dot product and orthogonal vectors in space. Remember how we found dot product is we took the first components, multiplied them together, then added it to multiplying the second components. And now for 3, we're just going to take the third components, multiply them together, and add it all up. So the cross product then is a1, b1 plus a2, b2 plus a3, b3. Vectors a and b are orthogonal if and only if their cross product is 0. Remember, orthogonal means that they form right angles. They're perpendicular. So let's look at these ones right here. Find the dot product of u and v, then determine if they are orthogonal. So uv, u times v, is going to be negative 7 times 5 plus 3 times 17 plus negative 3 times 5. So we multiply them together. Negative 7 times 5 is negative 35. 3 times 17 is going to be 51. And then negative 3 times 5 is negative 15. So I add up all of those together, and I end up getting 1. So once you add them all up, you get 1. Are they orthogonal? They are not. The cross product is 1. Let's look at the next one. U times v is going to be 3 times 4 plus negative 3 times 7 plus 3 times 3. 3 times 4 is 12. Negative 3 times 7 is negative 21. 3 times 3 is 9. I add up all of those and they add up to 0. So are these orthogonal? Yes, they are. So you can write forward. Meaning they are right angles and perpendicular. So there's a couple guided practice problems. Feel free to try those now. Next, we can also find the angle between two vectors. The equation, again, is the exact same as what we talked about when they were in 2 dimensions. So it's the same thing. Cosine of theta is the dot product of a and b divided by the magnitude of a times the magnitude of b. So what I'm going to do, you don't have to graph them, but I like to graph them just to kind of see what they're going to look like. Alright, so if I was going to graph the first one, u. So I'd go forward 3, over 2, and then down 1. Okay? So that's u. And now I can find v, which is back 4, over 3, and then down 2. So that's v. Okay? And our job then, what we're tasked to do, is to find the angle right there. So remember, the equation is cosine of theta is equal to the dot products divided by their magnitude. So first, I'm going to find the dot product of u and v. So what I have to do is, that's going to be 3 times negative 4 plus 2 times 3 plus negative 1 times negative 2. All over, and then it's going to be, remember, the square root of 3 squared plus 2 squared plus negative 1 squared times the square root of negative 4 squared plus 3 squared plus negative 2 squared. Alright, so 3 times negative 4 is negative 12, plus 6 would be negative 6, plus 2 would be negative 4 on top, and then this would be the square root of 14 times the square root of 29. So remember, cosine of theta is equal to that. Now I could simplify it all out just a little bit more. Otherwise, I can take my calculator and simply put it in how it is right there. Do the inverse cosine of both sides. And I find that theta is approximately 101.5 degrees. And I look at my picture. Does that look like 101.5 degrees? Yeah, it does. It looks like more than 90, but less than like 180. So 101.5 looks like the correct answer. The next thing we're going to talk about is cross products. And what cross products are is it's a vector formed between your two other vectors, A and B, such that it's perpendicular or orthogonal between vector B and vector A. So you'll see right here, if this is the cross product vector, my red one right here, notice it forms a 90-degree angle with vector A, and it forms a 90-degree vector with angle B. And that's in the third dimension. It's not in 2 dimensions, this is in 3. And so A cross B is how this is read. And the way we do that is we have to know what our two vectors are, and we find their cross product. Now to do this, you have to think back to matrices. And how do we find the determinant of a matrix? What we do is we take A, D, and then we subtract it from BC. So if I'm looking at a matrix right here, I take the crosses, cross, and subtract them. So in a 3 by 3 matrix, or I guess in this case it's a 3 by 2, you'll see that we have I, which is the original component, the unit component in the x quadrant on the x-axis. And so that multiplies by these two right here. Then we have j, which is the y component, which is these two. And finally k goes with these two. So it's a little confusing at first, but essentially if you look at it like I, j, k rows, I goes with the other two components of x and y from jk, and so on and so forth. And so then what we do is we find the determinant of each one. Okay? A2 times B3 minus A3 times B2. And that's my I component. And then I do A1 times B3 minus B1 times B1, and that's my J component. Finally, you'll see something a little different, is that this is plus, and then we have A1 times B1 minus A2 minus B1, and that's my K component. It might be easier to look at an example, so let's look at example 3. Find the cross product between two vectors. So first I need to create my matrix. I have the I, J, and K components for my two vectors. So for U it's 3, negative 2, 1, and for V it's negative 3, 3, 1. So first, let's make my I vector. So that's going to be negative 2, 1, 3, 1, and that's the I vector, minus, now it's the J vector, which is 3, 1, negative 3, 1, J, and then I add the K vector. So that would be 3, negative 2, negative 3, 3, and that would be K. Now my job is to go through each one and find their discriminant. So first, in the I, negative 2 times 1 minus 3 times 1. And that was going to be my I. Then I subtract 3 times 1 minus negative 1, negative 3 times 1, and that's my J component. And finally, I add my K component, which would be 3 times 3 minus negative 2 times negative 3, and that's going to be my K. So I go through. Negative 2 times 1 is negative 2, minus 3 times 1 is just 3, so negative 2 minus 3 would be negative 5i, minus 3 times 1 is 3, minus, and then negative 3 times 1 is negative 3, so 3 minus a negative 3 would be 6j, plus 3 times 3 is 9, minus negative 2 times negative 3 is a positive 6, so 9 minus 6 would be 3k. So now I have ijk. So this actually creates a vector. And so that's going to be negative 5, negative 6, 3. So now those are the components of my cross product vector that creates a right angle with both u and v. And what we can do is we can actually check that by finding the cross product, or excuse me, the dot product between u and this vector and v in that vector. So if I was going to do that, just a reminder, u is 3, negative 2, 1, and my cross product. So if I was going to find my dot product, okay, so it would be u dot u cross v is going to be, well, negative 5 times 3 plus negative 6 times negative 2 plus 1 times 3. And so negative 5 times 3 is negative 15 plus positive 12 would be negative 3 plus 3 is 0. So are those orthogonal? Yes, they create a 90-degree angle. And we can do the same with v. Remember, v's vector was negative 3, 3, 1. And so I take my cross product. Okay, so I'd say v dot the cross product, u cross v. And so I get negative 5 times negative 3 plus negative 6 times 3 plus 3 times 1. Well, negative 5 times negative 3 is positive 15 plus negative 6 times 3 is negative 18, so that's negative 3 plus positive 3 is 0. So it's orthogonal to both of them. So did we do this correctly? We did. So this right here is u cross